Hello students, today we are going to discuss about new subpoint, that is structure and shape of organic molecules. Just we recall one of the familiar term in organic chemistry, that is hybridization. All of you are much more familiar with the term hybridization. When a new molecule or different molecules are developed from atoms like carbon, hydrogen, and oxygen. For example, organic molecule like methane, that is first member of organic molecule having molecular formula CH4. It needs the important process, that is hybridization, due to which a new bond between carbon and hydrogen as well as carbon and oxygen is developed. Okay, so hybridization is the phenomenon or the process which is useful to construct a new bond between any two atoms, right? So two atoms, whenever combined with their atomic orbitals and again redistributed, then we are getting hybrid orbitals from atomic orbitals. Whenever we have to define the process of hybridization, that is the mixing and redistribution of atomic orbitals of different energies in an isolated atomic form so as to develop a set of new orbitals with equal energies. The overall process is known as hybridization, while the new orbitals are called as hybrid orbitals. Okay, for example, in the atoms there are presence of four different types of atomic orbital. Which one? That is, a simple atom like hydrogen contain s orbital. Other atoms like carbon, oxygen, nitrogen, sulfur contains p orbital, while the atoms with higher atomic number contains d and f atomic orbital. So there are four different types of atomic orbitals, that is s, p, d, and f, right? So these are the four atomic orbitals present in different individual atoms s, p, d, and f. All these atomic orbitals are always having different energies. Okay, so energy level of s orbital is always lower than p, d, and f. So s is having lowest energy level while f is having highest energy level. So whenever individual atoms are considered, then they are having different energies. But whenever these atomic orbitals are combined during the process of hybridization, and again they are redistributed, we are getting a set of atomic orbital, sorry, hybrid orbitals with equal energy orbitals are obtained, and those new atomic those orbitals which are developed after hybridization are called as hybrid orbitals, right? So hybridization is simply defined as the process of mixing and a redistribution of atomic orbitals so as to give a set of different orbitals with equal energies, that is hybrid orbital, and the overall process is called as hybridization. So these atomic orbitals are having different energies. Second thing, shape of this atomic orbital is also different, and the shape is simply termed as a symmetry of atomic orbital. That is S, P, D and F are having different shape as well as energies, and whenever these atomic orbitals are combined, the process is called as hybridization. Now all of you are more familiar with three different prominent type of hybridization. Which one these? There is first type, SP3 hybridization, which is observed in methane molecule, that is CH4. First is the SP3 hybrid orbital, and this hybridization is also called as a tetrahedral hybridization. Then second type of hybridization is SP2 hybridization, that is also called as a trigonal hybridization, and third one is the SP hybridization, it is also called as a diagonal hybridization. So these are the three basic type of hybridization, that is SP3 hybridization, tetrahedral hybridization. Second one is the SP2 hybridization. It is also called as trigonal hybridization. And third one is the SP hybridization, called as a diagonal type of hybridization. So these are the three basic type of hybridization, and all of you are much more familiar with these three basic type of hybridization. Second, second thing. Now first we see the shape and symmetry of a three different atomic orbitals. Okay, three different atomic orbitals which is shown in this slide. Okay, that is S orbital having the shape, that is a spherical shape. So 1s, 2s, these s orbital which are present in different types of atom always having a spherical shape like a ball or sphere, that is a rounded type of shape or circular shape or spherical shape. This is the basic shape of this s orbital. Then p orbital and their orientation are always three type, that is 2px, it is a dumbbell shaped atomic orbital. Py is also dumbbell shaped atomic orbital, and Pz is also dumbbell shaped atomic orbital. Now how they are distinguished? That is, p orbital is always having dumbbell like shape, but according to their orientation on axis, that is x axis, y axis and z axis, those p orbital which is oriented along horizontal manner on x-axis, this is always px orbital. Those atomic orbital which is oriented on y-axis, this is py atomic orbital, and those atomic orbital which is located or oriented along with z-axis, this is always p said orbital. So p orbital is having dumbbell like shape, that is dumbbell shaped, and according to their orientation they are px along with x-axis, py along with y-axis, and pz along with x-axis, which is shown in this particular slide. Now these are the three basic shape of this particular molecule. Then whenever this shape or according to their orientation molecules or atomic orbitals are mixed, then we are getting a hybrid orbital. So this is about a shape of atomic orbital of s and p. Now we are moving towards a first type of hybridization, that is sp3 hybridization or a tetrahedral hybridization. Now first we see what is sp3 hybridization. In sp3 hybridization, always one 2s orbital, एक 2s ऑर्बिटल यूज केले जाते आणि 3 p ऑर्बिटल्स यूज केले जातात. सो 1s ऑर्बिटल and 3p orbitals are mixed with their different energies and again redistributed so as to give 4 number of sp3 hybrid orbitals. The overall hybridization is called as sp3 hybridization. Look at here. S, it is having 1s orbital and 3p orbitals are used. Means total atomic orbitals which are used in this mixing process are totally 4. That is 1 2s and 3 2p orbitals are mixed with their different energies so as to give 4 number of sp3 hybrid orbitals with equal energies, and the overall process is called as sp3 hybridization. Those hybrid orbitals which are formed with equal energies, they are having tetrahedral symmetry. Okay, their symmetry is what? A tetrahedral. Now first we see, this is the simplest definition of sp3 hybridization, that is by mixing of one 2s orbital and 3 2p orbitals of carbon so as to give 4 equivalent sp3 hybrid orbitals which are directed in the corners of regular tetrahedron, and the overall hybridization is called as a tetrahedral hybridization or sp3 hybridization. Okay,